Hey everyone, welcome to the Earth, Moon, and Sun unit launch video. My name is Audrey and I'm an 8th grade science teacher from Chicago, and I'm really excited to walk you through this unit. In this unit, the phenomena students are working on is that they are working with an astrophotographer to plan for the best times to take photos of specific features on the moon. Before I get into talking about the big question in the unit, there is some pre-work that you should make sure you have done. If you haven't, it's no problem, just pause the video and hit resume once you finish the pre-work. Great, now we are ready to go. So why does this unit matter? First, our students see the moon every night, and they know that it looks different, but they most likely have no idea why. It is so cool to watch kids learn about something that they have been wondering about for their whole lives. Second, I truly believe that anytime students are learning about space, they are pushed to think outside the box. They have to think about the unknown and the unfamiliar, and that's an important skill not just in science, but in life. So let's get into looking at the specifics of the chapters. In the first chapter, students work to answer the question, why is there a border between light and dark on the moon? Students are introduced to the astrophotographer, and they learn that he wants to take pictures of 3 different craters on the moon. They learn that it is easiest to take these pictures when they are near the terminator, the border between light and dark on the moon. On the second day, students continue to investigate the Chapter 1 question by completing a hands-on investigation. In this unit, students will use moon sphere models and light in their hands-on activities. In this first activity, students learn that the sun illuminates the half of the moon that is facing it, and so that is why we have the terminator. On the last day of the chapter, students then use what they learned in the hands-on investigation and take that knowledge deeper by using the sim and the modeling tool, showing again that half of the moon is always illuminated and half is always dark. By the end of the chapter, students should have mastered Progress Build 1, which means they know that we see the moon because the sun illuminates the half of the moon that is facing it. Students are able to show their knowledge of Progress Build 1 on the Chapter 1 focus task. Take a few minutes to complete the task. Press pause on the video and then just hit resume once you have finished. Awesome. Here are the answers to the focus task. Students should show and explain that the half of the moon facing the sun is light and the other half is dark. Students receive 4 points for the model and 4 points for the response. You can check your answer with the online rubric. Pause the video if you need some more time to read over the exemplar and just hit resume once you have finished. So now in Chapter 2, after students know why there is a border between light and dark on the moon, they are figuring out why does the border between light and dark on the moon change location. Students begin the chapter by actively reading about moon phases. On the next day, after rereading the article, they use the moon sphere models again. They're trying to answer the investigation question. Half of the moon is always illuminated. Why does its appearance from Earth change? And they have 2 claims. The moon's appearance changes because Earth casts a shadow on the moon, or claim 2, the moon's appearance changes because the position of the moon changes. Through this activity, they're able to decide that claim 2 is correct. And so once they have learned about this, they're able to then take what they know to use the sim and the modeling tool to create those phases themselves. On the 4th day of the chapter, students use their moon sphere models again to model the orbit of the moon. And they return to the modeling tool to try to order the phases. So this is where they learn that the phases do not appear randomly, rather they are a pattern because the moon moves in a predictable circular orbit around the Earth. On the last day before the critical juncture, students create diagrams that show the moon at each position in its orbit. The diagrams show the view from Earth as well as the top view. I, as you can see here, made this project into a large poster project rather than just completing it in a packet or something, and I found that it was one of the most helpful activities of the entire unit. Students had a ton of fun doing it, as you can see, and they were able to walk away with a huge visualization of why we see the different phases and when we see the different phases. It was awesome. By the end of the chapter, students should have mastered Progress Build 2, which means they know that the moon's repeating cycle of phases is caused by the moon's changing position in its orbit around Earth. Students are able to show their knowledge of Progress Build 2 on a chapter focus task. Take a few minutes now to complete the task. Pause the video and just hit resume once you have finished. Great, here's the exemplar. Students should show and explain that half of the moon facing the sun is always illuminated, but since the moon orbits the Earth, the appearance from Earth changes. Students receive 4 points for the model and 4 for the explanation. You can check your answer with the rubric online. If you need more time to look it over, pause the video and resume when you are done. In Chapter 3, Now that students have learned about moon phases, they tackle a new question. What are the conditions that cause a lunar eclipse? To start the chapter, students are now introduced to the 3-view mode on the sim. Previously, they only saw the top view and the view from Earth in 2-view mode. Now they see the system view as well. Students also return to the moon sphere model, helping them to see that when the Earth, Moon, and Sun are directly aligned, there can be a lunar eclipse, which means the moon is completely dark. On the next day, students actively read an article about how ancient scientists were able to predict when lunar eclipses would occur. Students then used the sim to see that normally the moon orbits on a tilt, so there is a full moon when the moon is behind the Earth. But rarely, the Sun, Moon, and Earth are directly aligned, causing the Earth to block light from hitting the moon. On the last day, students look at evidence to explain why and when lunar eclipses occur. By the end of Chapter 3, students should know that lunar eclipses happen during relatively rare moments when the Sun, Earth, and the Moon are perfectly aligned. If they know this, they have mastered Progress Build 3. Students again show that they've mastered the progress build by completing a chapter-focused task. One thing to note is that this is the only focus task where it's essential to complete the model online. There are a lot of different parts that would make it really hard to do on paper, and so make sure that your students have Chromebooks or laptops available for this task. Take a few minutes to complete the task yourself. Press pause on the video and hit resume once you have finished. Now that you've completed the task, here is the exemplar. Students should be able to explain that usually when the moon is behind the Earth, there is a full moon because the moon orbits on a tilt. But sometimes, if the Earth, Moon, and Sun are perfectly aligned, there is a lunar eclipse. The students earn 4 points for the model and 4 for the response. You can check your answer at the online rubric, and if you need more time to continue looking this over, just hit pause and hit resume once you are ready to move on. Now in Chapter 4, students apply all they have learned to a new phenomena. In this case, the question is really awesome, and it is, will there be a lunar eclipse of the moon of Kepler 47c during a given year? On the first day, students learned that Kepler 47c is a planet located in a 2-star system. It also has its own moon. Students have to decide whether or not there will probably be a lunar eclipse of the moon of Kepler 47c during a year. So in this case, the claims are actually pretty simple. Claim 1, yes, there probably will be a lunar eclipse. Or claim 2, nope, there probably won't be a lunar eclipse. Students are going to look at multiple pieces of evidence. For example, they complete this model to show that for Earth, a lunar eclipse is possible in any position on Earth's orbit. Because in any different position the Earth is in, there is a chance that a lunar eclipse could happen when the moon is behind the Earth. In the 2-star system, however, because there's light coming from 2 different points, the lunar eclipses are only possible when Kepler 47c is at position 1 or position 5. So by looking at evidence like this and many other pieces of evidence, students craft their arguments and engage in the seminar. The day after the seminar, students use what they learned to complete their Chapter 4 task. Take a few minutes to complete the task. The evidence cards are available on Amplify. Pause the video and hit resume once you have finished. Now that you've completed the task, here are the exemplar answers for each claim. Take some time, if needed, to pause the video to review the rubrics online and read through these exemplars. Hit resume once you are ready. Great, so now students have completed the 4 chapters and they are completely ready for their end of unit assessment. So we're going to go through a couple of those questions now so that you know what that will look like. Here's a Progress Build 1 question. Take a few minutes to complete the question. Hit pause and resume the video once you've answered it. The answer to this question is C. Students who choose this answer know Progress Build 1, which is that we see the moon because the sun illuminates the half of the moon that is facing it. The only possible answer is diagram C, because this is the only diagram where half of the moon is illuminated. Here's a Progress Build 2 question. Take a few minutes to complete the question, hit pause, and then hit resume once you have finished. The answer to that question was D. The key is that students here know Progress Build 2, which is that the moon's repeating cycle of phases is caused by the moon's changing position in its orbit around Earth. So they really need to understand that the appearance of the moon changed because the position of the moon changed. The most common wrong answer is A, which is that the moon moved further away from the sun, so there was less sunlight reaching it. That misconception is one that you want to make sure to clear up and make sure students understand that we see different phases because the moon is moving, but half of that moon is still always illuminated. Here's a progress build 3 question. Take a few moments to answer it and hit resume once you are ready to go. The answer is D. These questions got a little bit tricky for kids. They need to know that in diagram 2, the half of the moon facing Earth is not illuminated by the sun, so it will always be dark because that is a new moon phase. Additionally, students should know that at position 1, although it is usually a full moon, occasionally a lunar eclipse can occur. So this is really getting students to understand that there are 2 key times that the half of the moon facing Earth can be dark. During a lunar eclipse, which happens sometimes, or during a new moon, which happens always. If they've done this, they know progress build 3, which is that lunar eclipses happen during relatively rare moments when the sun, Earth, and the moon are perfectly aligned. Now, let's look at the constructed response. It says, Felipe believes that whenever the moon is in the position that is shown from above in diagram A, the moon always looks completely bright in the view from Earth as shown in diagram B. Is Felipe correct? If he is correct, explain why the moon always looks bright from the Earth in that position, and explain how you should show light in diagram A. If he is incorrect, explain how else the moon can look when it is in that position. Hit pause on the video and hit resume once you've completed the response. Here's an exemplar response. Felipe is not correct. Sometimes when Earth is in a straight line between the sun and the moon, it blocks the sun's light from hitting the moon, and there is no light on the moon at all. His model is not always correct, only sometimes. An exemplar answer notes again that Felipe is incorrect, and students should be able to articulate that although sometimes Felipe's diagram is correct, if the Earth, moon, and sun are in a straight line, a lunar eclipse can occur. This type of answer shows that students have knowledge of all 3 progress build levels. Thank you so much for watching this video. I had so much fun teaching this unit. I found that using models and drawings and extras really took this unit to a whole new level, and it was a ton of fun, and I'm confident that your kids will have so much fun with it too. You're going to have a blast. Lastly, some final steps for KIPP teachers. Pause if you need some time to go over this, but otherwise enjoy Earth, Moon, and Sun. It's the best. Thank you.